Hello everyone, welcome to Mydbops OpenSource Database Meetup 16 recorded live in Bangalore. Mydbops excels in open source database management, offering tailored solutions for MySQL, MariaDB, MongoDB, Postgres, TiDB, Cassandra, and more. Mydbops organizes meetups to facilitate knowledge sharing, networking, and collaboration among professionals in the field of open source database management. Coming back to the recording, Mydbops was thrilled to present Mayank Prasad, a lead developer in the MySQL-InnoDB Development Team, who dived deep into the MySQL-InnoDB Storage Engine. He explored two improvements implemented in MySQL 8.0. One is dynamically configurable redo log size, and the second is instant add drop columns. This session offered valuable insights for anyone interested in database management. Without further ado, let's dive into the insightful presentation.
Hello everyone. So my name is Mayank. I'm working with MySQL since 2011, and I'm working with InnoDB team since 2017. And this will be the agenda of today's talk. I'll talk about this configurable redo logs, dynamically configurable redo logs, and then instant add and drop columns. So I've talked about this instant add and drop column and given an overview on multiple platforms. But in this presentation, I'll go deep into how this feature is implemented, the design and all. Right. So redo log is a write-ahead logging in InnoDB. So when I say write-ahead logging, it says before we write the actual data to the disk, we write this information of changes into the log and then flush that data to the disk. Why do we do that? Is because when you, let's say there are two transactions, T1 and T2 are modifying the same page in the database. If T1 has to be committed, right, the data has to be persisted on the disk. And if you try to persist each and every page after the modification is done, then the IO will become bottleneck. So instead of, so let's say T1 has modified 1 byte in a page and the page size is 16 KB. So for 1 byte modification, we are flushing 16 KB page. That doesn't make any sense. So what we do is we bring the page into the buffer pool. We modify that 1 byte, but we don't flush this page. Before modifying the page, we write this modification information into a redo log, very concise information, and then we flush that information to the disk. And then we don't flush the page. So the T2 can come up and modify the existing copy of the page in the buffer pool itself. So that's what the write-ahead logging is all about. In MySQL, the redo log is maintained as a circular buffer on the disk. So that means it has a fixed size, and it's a circular buffer. It's kind of a snake which eats its own tail. So it keeps on overwriting the redo data, which is not needed anymore. Okay, so as I said, with the redo log, we avoid the flushing of buffer pool pages, right? But what's the drawback if you have a very big redo log? So you can have a very huge redo log, and then you can avoid flushing of database pages. But the problem is if there is a server crash and when you restart the server, the recovery will take that much of time because you have to pass the entire redo log and then apply those changes. But at the same time, if you have shorter redo logs, that means you have to flush aggressively, because the redo log has to be truncated frequently. So what should be the optimal size of a redo log? That depends on your workload and trial and error. So for few people, 100 MB of redo log must be sufficient. For few people, 1 GB might not be enough. So then once you know what should be the size of the redo log, you can set it. And in MySQL, we talk about redo log size in InnoDB log file size parameter. But the thing is, this parameter cannot be modified at runtime. So your server is running, you have set a redo log, but now you decide, oh, I need to increase the redo log size. That cannot happen because this is not dynamically configurable. So there were requests from the customers and the community that is it possible to make this configuration dynamic? So that's what we did. Even now, redo log is a circular buffer on disk, but now instead of redo log file size, we talk about in redo log capacity. So we say what should be the capacity of your redo log, let's say 100 MB or 1 GB. So that you can set. This is not a single file on disk now. It is a group of files, and these files size and the number of files is calculated based on the capacity you set. And now you can dynamically configurable this InnoDB redo log capacity when the server is running. So if you go and look inside this InnoDB data directory, MySQL data directory, you will have a separate folder which is called InnoDB redo. This is where we keep all the files which are being used as to make a circular buffer of redo log. So you see there are few files which have suffix s_tmp and the few files which don't have suffix _tmp. So the files which don't have suffix _tmp are the files which have REDO logs which is needed for the database persistence or consistency. The files which are _tmp suffix, they are the empty files which can be used for the REDO log to write the new REDO logs, right? And they might have old REDO logs which are not needed. When I say REDO logs, what could be the REDO logs which are not needed? I'll explain in the next slide. Right. So if I put all these files into a single line, so this is how the REDO log capacity looks like. So the white portion at the end of the this line says the REDO log files which are _tmp, which are available to be written now. This red portion is the area where we have the REDO logs which are needed for database consistency. We cannot truncate this area because these are the REDO logs which have not been flushed to the disk. I mean, the changes of the pages have not been flushed to the disk. And this is the area where we have REDO logs for the changes on the pages, but those pages have already been flushed to the disk. So these REDO logs are not needed anymore. And the checkpoint lesson is the point which decides up to what point you can truncate the REDO log. So anything before checkpoint lesson is the thing which is not needed for the database consistency because pages are already there on the disk. Now, if you want to have, now we have this mechanism in which we can just to get the more size of the REDO where we can write it. We just delete this entire area and then add it to the tail. So this is how it will look like. Now these files will be deleted. They will be renamed as _tmp, and then they are available to get the more REDO log to be written into. And let's say you have set a REDO log capacity of some x MB, and the REDO logs which you are generating is more. Then you might get this error on the or a warning on the server log saying that your REDO log capacity is less. Try to increase it now. Otherwise, it might become a bottleneck. And we have the instrumentation in performance schema. We have added that. So you can look into the performance schema table in InnoDB REDO log files. And then you see list of files which are having the REDO logs. They also say what is the start LSN from where this file has the REDO log from, and the end LSN up to which the REDO log files are there in this particular file. And so you see there are 1, 2, 3, 4, 5 REDO logs files which are available in this performance schema instrumentation table. And these are the 5 REDO logs which are on the disk without _tmp suffix. So that means these are the files which are having the actual REDO log which are needed for the database consistency. Right, so as I said, the REDO log file can be, or the capacity can be changed dynamically. So let's say I want to make my REDO log file capacity as 200 MB. I run this command, set global InnoDB REDO log capacity is equal to 200 MB. If you are resizing it up, let's say your REDO log file size is less or capacity is less, you are increasing it, it is instant, right? So we just have to calculate how many files should be there and what should be the size of each file. But if you're resizing it down, then you might already have the REDO logs which are not yet flushed or they are still needed. So this thing happens in the background. And how do you know whether this thing has completed? You can go and see the show status like InnoDB REDO log files, REDO log resize status. If it is showing resizing down, that means the background process is still going on. If it shows OK, that means the resizing has been done. And this show status like InnoDB REDO log capacity resize, you can see the current capacity of REDO log. Now I'll talk about the another feature, which is instant add and drop column. This is very low level details in the code, how this feature has been designed and implemented. So if you have any question at any point, you can just stop me. Yeah, before we understand how the instant add and drop column has been designed and implemented, we need to understand the page on disk page format of InnoDB. So let's have a look. So this is how an index page in InnoDB on disk looks like. Every page has two dummy records which are called infimum and supremum. Infimum is the first. All the records on a page are adjusted, or they are put in a singly linked list. So every previous record is always pointing to the next record. And the head of the linked list is infimum, that is a dummy record, and the tail of the linked list is supremum, that is the last record on the page. And in between we have this records which are inserted by the user. And every record you see, they have two parts. One is the actual raw data, which has been inserted by the user, and the metadata. So this metadata is what using which we interpret the records when we read it from the disk. What this raw metadata could be, it could be the null bitmap of the nullable columns, it could be the length of variable length field records, etc. So let's look into this raw metadata part. If we look inside this raw metadata, we see there are two parts it is made up with. One is variable size row header, one is fixed size row header. And the fixed size row header is 6 bytes if the row format is redundant, and it is 5 bytes if the row format is compact, dynamic, and compressed. So any record in InnoDB on disk will have this fixed size header based on the row format it has been used. Now, if we open this and look inside this variable size row header, it has again two parts. One is variable length, fields length, and null bitmap. What is this variable length, fields length? So you might have table definition. You might have columns like varchar 100. But on disk, you might have, let's say, inserted Mayank. So only 6 characters has been used, whereas you have decided 100. So here we store for this particular field what is the size reserved on the row. So in this case, it will be 6. The null bitmap is a bitmap which says whatever nullable columns are there in table definition, in this particular row or in this particular record, how many columns are null. So that's the nullable bitmap gives us. This nullable bitmap is not available in redundant row format. They have their own mechanism to find out the nullable columns. So we saw the disk format of every records. It is very clear that every records has number of columns, column specifications to interpret the row, right? So if you are going to add and drop a column, that means every record has to be modified because the interpretation of the row depends on the number of columns what the row has or what the table has. So if you do that, it will do a table rebuild. It has to go read in each and every row and then reformat it to the new definition and then insert it again. This is a very costly process. It takes time, it takes resources. And if you're running a replication, then this has to be done on masters. Let's say it takes X amount of time. It goes to slave. Again, it takes X amount of time. So that's a big requirement or big ask from the customers. Is it possible to reduce this thing? Because that's a big pain point. So the idea behind solution which we have come up with is it possible to modify only metadata somewhere and don't touch the rows on the disk? And with this metadata, is it possible to interpret the rows correctly? If it is possible, then we can save the times whatever we have spending in the previous mechanism, and the replication will also get benefited by that. Table will not be locked for a very long time. So that's the whole idea behind it. So with this inspiration, we implemented something in 8012, where we say alter table add column with algorithm is equal to instant. This was possible to add a column, but the limitation was the column can be added as the last column in the table. So you cannot add the first column or you cannot add any column in between. And it supports only instant add. I mean, you cannot drop a column instantly. If you're going to drop a column, then again, you have to read each and every row and transform it. Then we went back to the scratch pad and we came up with a new design. With this new design, now it is possible to add a column anywhere in the table definition, be it the first column, somewhere in the middle, or at the end. And it is with the new design, it is possible to drop the column as well. And this is the syntax. How did we do that? We introduced something called row versioning. So every time we do an add column or drop column, we bump the row version of the table. And this row version is stamped on the row when the row is inserted to the table. So let's say table has gone to X number of alter, add, and drop. So now the version number is, let's say, XV. So this now if you insert a row, this XV will be stamped on the row. And when we fetch the rows, so let's say you might have the old records which are not having any version, but now the version is XV. So we transform this thing when we fetch the rows. How this transformation happens, I'll show in the next slides. Before that, let's understand where we stamp the this version on the disk. So this is a 6-byte header for the redundant row format. It has multiple information. And the last one is this info bits. In the info bits, the green one, this is the free bit which was available. It was not being used. So we used it to indicate whether this particular row, which is there on the disk, has a version stamped on it. So if this bit is 1, That means there is a 1 byte version information available on the disk. Similarly, we have this 5 byte row header for compact, compressed, and dynamic row format. And same info bits, the second last bit was available, we used it. And if this bit is 1, it says there is 1 byte version information stamped just before this row header. So now with this thing in our mind, if we look at any row on the disk, if the row doesn't have any version, that means if that bit is 0, this is how the row would look like. It will have the row metadata, which will have 2 parts: variable size row header, fixed size row header, and the actual row data. But if this bit is 1, this is how the row would look like on the disk. It will have row data, row metadata, variable size, and fixed size, and in between there is a version stamped with 1 byte. Okay, so as I said, how do we transform something existing row to the latest version, whatever is available now? So these are the information available on disk. When we read the row, we can read the record version. We have columns, metadata. If the column is added, we store this information in which version this column is added in data dictionary. If the column is dropped, we store this information in which version this column is dropped in data dictionary. With these two information, it is easy to understand how the row has to be interpreted. So if any column has version dropped is equal to 0, greater than 0, that means this column does not exist in this table anymore. So when we read this row from the disk, we ignore this column. And if any column which has version added greater than the version of the record which is there on the disk, that means this column data is not there on the disk. So we take the default value of that column and append to the disk, append to the row which we are fetching, and then present it to the user. How? Let me give you an example. So let's say I created a table which has 4 columns: C1, C2, C3, and C4. And because we have not done any instant add and drop, the version is 0. Now I inserted a row. So how the row looks like on the disk? It will have VC1, that is value of C1, value of C2, value of C3, value of C4. So that's the row data part. This red part is the metadata part, row header, where the version is not there, right? Because this row doesn't have any version. Now I did alter table drop column C3. So now column C3 has been dropped. So this information has been noted down in the data dictionary that this column is dropped in version 1. Now we did add alter table add column C5 with these default value. Now the table version has gone to 2, and this C5 has been added. How the data dictionary looks like? This is how it looks like. It says for C1, added drop is 0 because it has not been added instantly. Same for C2 and C4. But for C3, the version dropped is 1. That means this column has been dropped in version 1. For C5, the version added is 2, and that is the default value. So now this information is on data dictionary. That information is on disk. And if we fetch this information, fetch this row, what we get? We see nothing is stamped on the row, so the record belongs to version 0. Current version of the table is 2 from the data dictionary. We see C3 was present on the disk because it is the row is version 0, right? So C3 value is there on the disk, but C3 isn't present now, so we have to ignore the value of C3. Now when we fetch this row, read the row from the disk, this is how we do. We take the value of C1, we take the value of C2, but we don't take the value of C3. We ignore this information, and we take the value of C4. But now C5 is also there. So where do we get the value of C5? We get it from the data dictionary. And this is how the row will look like finally. So on disk row is that VC1, VC2, VC3, VC4. But when you fetch it, you will get this VC1, VC2, VC4, VC5. That's how the transformation of the row happens. And let me give a full flow how this instant add and drop works. So let's say I have a table which has row R1 and R2. Both of them have no version because no instant add and drop has been done. Now I do DML. I update R2, R2 dash. Still no row version on the disk because no instant add and drop has been done. I do another insert, make R3, same, no row version. And now I did an instant add and drop, be it add or drop, whatever I did. So what it does is it stores the metadata into the data dictionary, which I told you about, right? The column metadata and the default value of the column if it is being added. And in this DDL, we don't touch any records on the row. So the rows on the disk are as it is. Now if I do a DML insert, the R4 will have version 1 stamped because now the current version is 1. And if I do a DML update, R3. So we transform this R3 to the R3 dash and stamp the version 1, because now this has been updated after the table version has changed. And if we fetch this information, we take the data from the disk, we take metadata from the data dictionary, and we fetch it. So we don't have to transform R4 and R3 because they were already in the latest one, but R1 and R2 are supposed to be transformed. This instant algorithm is default when you do alter table add drop column without giving any algorithm is equal to instant, algorithm is equal to clause. So what we do is any add and drop column goes through instant, but if instant is not possible, it falls back to copy or in place. What are the cases when instant is not possible? I will explain in the next slide. If you do any optimized table or any other alter table, which is doing the table rebuild, this instant metadata will be reset. The column metadata will be reset in the DD, the version added, version drop. Row version will be reset to 0. And if you do a truncate table, that means you are getting away with all the records in the table. Then instant metadata does not make any sense because there is no records. So that also reset the instant metadata. Now we realize this adding and dropping column is not a very frequent operation in real world, right? So a customer who is running table, it cannot keep on adding and dropping columns. So because this is a rare operation, we limit this number of instant and add drop operation to 64. So up to 64 row version, you can do instant add and drop. But if you go beyond that, and if you give algorithm is equal to instant, then you will get this error that maximum row version has been reached, now go fall back to copy in place. But if you have not done algorithm is equal to instant explicitly, I said implicitly it will take on instant path, then it will automatically fall back to copy. So you might see for 64 versions, you have your add column has been very fast, but when you did the 65th time, it took a lot of time because it has already fallen back to the copy algorithm. As I said, right, it will reset the instant metadata. Okay, as I said, we have implemented one implementation in 8.0.1.2, and we have implemented a new mechanism in the latest one. So how about a scenario when a customer is in 8.0.1.2, it has added some rows, or added some columns, and then after that it has some rows. It upgrades to the latest version. Again, it do some add and drop, and then add some rows. So in that scenario, on disk, we might have these kind of rows. There might be a row which is inserted before the first implementation of instant add is done. There might be a row which is inserted after you did an add column with the first implementation. Then you upgraded table to the latest version. Then you inserted some row. So those are the rows which are inserted before the new implementation of instant add and drop. And then you did add and drop, and then you inserted some new rows. So all these kind of rows are taken care. And when you fetch this data, it is presented to you in the latest version or in the correct table definition form. And if you want to get away with all this information on all this nuisances of processing this, just do the optimized table, it will reset the table into the latest version. For import and export, yeah, so we support import and export with this information as well. But if you're, in MySQL, there is a CFG file, the configuration file getting generated when you do an export table. But this CFG file was not must because when you do import, we can read the IBD file and take out the information and import it correctly. But if a table has this instantly add and drop column, this CFG file is must because that's where we store the instant information or instant metadata, which is used at the target server when you import this table. So this is the table which explains what are the supported. If your table doesn't have any, source table doesn't have any instant add drop, destination doesn't have any instant add drop, yes, it is allowed. If source has instant add drop, destination does not have instant add and drop, but a destination table definition is exactly like the source table definition currently, then the import is also allowed. If your source does not have any instant add and drop and destination has some instant add and drop, it's not allowed because we don't know what column you have added, what column you have dropped. And if both of them have instantly added and dropped column, the import is allowed only if the metadata or instant metadata is matching exactly. Apart from that, we have some observability as well. So let's say I have a table, create table T1 with column C1. In information schema, InnoDB tables, I can see information about this table T1. It says end calls is equal to 4 and total row version is 0 now. But the number of columns were 1 only. We have made table with the 1 column. Then why it is 4? And does anybody know why it is 4? Okay, so in MySQL, a row, when it is inserted on disk, it always have 3 extra column. If the table does not have a primary key, InnoDB internally generates a row ID. So that row ID is always written to the disk in this row. Then it has a transaction ID stamped on each and every row, which says which was the transaction who has modified this rows, latest transaction who has modified this rows. And then we have a rollback pointer. Rollback pointer is the undo log pointers using which you can create the previous version of the row. So that's why it is 4. So n calls is 4, total row version is 0, and this instant call was implemented in the previous implementation of instant add, but we have kept it as it is because we might have tables which have rows which were inserted before. So when we upgrade those tables to the latest one, this metadata should show that which column has been added instantly in the previous implementation. And then we have information schema InnoDB columns as well, and we want to see the information about column C1 which we have inserted. So we see has default is equal to 0 because it has not been inserted instantly, and the default value is anyway null. Now what I did is I did a add column C2 with a default value of something as a first column. Now if you see, the n calls has become 5, which is correct. Total row version has bumped to 1. And the default value is, it has default value because it is added instantly, and this is the default value of this column. So this default value is encoded internally, which is decoded when we fetch this row. Okay, so now time to see whether this is actually instant or not. I mean, I give a very big lecture, instant, but does it really work? So this is what I did on my development machine. I have a table with 8.3 million rows. And I try to add a column C4 with algorithm is equal to copy. It took 29 seconds. Then I add a column C5 with algorithm is equal to instant. It was done instantly. So yeah, this is a debug version, so don't go with the numbers, but this is just to show the comparison. So we have some limitations as well. We don't support instant add and drop for compressed tables. We don't support this if the table has a full text index in it. We don't support this instant add and drop for the DD tables. So DD tables, anyway, user is not supposed to or not allowed to modify. And we don't support this instant add and drop for session temporary tables. And yeah, and I have written 2 blogs which talks in deep about this feature, how it is implemented. So yeah, you can go. It has a lot more details about this feature. Yeah, that's it.
Thank you for joining us for this insightful session from Mydbops OpenSource Database Meetup 16. We hope you found Mayank's presentation on MySQL-InnoDB Storage Engine valuable. We will be releasing videos featuring our next speaker soon. Stay connected with us by subscribing to our channel for more informative content. We invite you to join us at our next event to continue learning and networking with professionals in the field of open source database management.